Hello, hello. All right, today's a little bit of math, huh? And we're going into chapter 4, lesson 1, and we are gonna start the process of breaking away from multiplication as basic facts. Okay, our 5 times 6s and our 3 times 7s and our numbers are going to get a little bit bigger. Okay, so we're talking about multiples of 10, 100, and 1,000. Now remember, a multiple is a number, or is the product of a number multiplied by another number. And multiples of 10, 100, and 1,000 are all numbers that are divisible by 10, 100, and 1,000. And we get to use multiples to help us today, and we also get to use patterns. Okay, so remember that we're going to be looking for a pattern that's going to help us multiply numbers like 60 and 600 and 7,000. And so to do so, I would like for you to have out page 199, which is your independent practice for chapter 4, lesson 1. And we will begin the process of multiplying some larger numbers. Okay, but we're going to do it by visualizing patterns. So take a look here at number 5, and we are going to use basic facts and a pattern here to solve all of these problems. You can see I have 5 all the way to 21 circled here. Okay, so let's see. Let's look at number 5. We have on the top, okay, and then 3 more number sentences below it. So what this is saying is if you can multiply 5 times 3, then you can certainly find a pattern and use a pattern to multiply 5 times 30, 5 times 300, and 5 times 3,000. Okay, the pattern is going to be visible to some of us, but as you see, the 0 increases by 1 as we work our way down the list. They said that 5 times 3 is 15. So then they said 5 times 30 is 150. So what's the pattern that we see in these two number sentences that's going to help us figure out what 5 times 300 and 5 times 3,000 is? And what I'm seeing is they're kind of pretending like the zeros aren't there. Okay, and they're just going to continue multiplying 5 times 3. So 5 times 3 again is 15, except where you saw 30, you saw an extra 0 there. Look what they did. They put that extra 0 right there. This is number 1 within Mountain Math. Okay, so let's do the same thing here. Just pretend it's 5 times 3, 15. But how many zeros do we have to add from the 300? There's 2 of them. Okay. And then 5 times 3 is 15. And how many zeros do we have to add to the end of that? 3 of them. Okay. All right. 3 times 4 is 12. Again, 3 times 4 is 12. And how many zeros are you adding? 1. 3 times 4 is 12. How many zeros are you adding? 2. 3 times 4 is 12. And how many zeros are you adding? 3. Okay. So here's what I want you to do. I want you to take a look at this. And I want you to, before actually I send you on this, let's look at this one here. This one is tough, right? Because check out these basic facts. 3 to 5 times 3 is 15. There's no 0 there. 3 times 4 is 12. There's no 0 there. There's nothing that's going to get us confused. But here, 8 times 5, by using my multiplication table, 8 times 5 is 40. I have a 0 here. So a lot of times when we go down to do 8 times 50, we say 40. Because why? Because there's 1 0 there. Kids, you got to go back to the basic fact. Okay, so if there is a 0 in that basic fact, it does not count for any of these zeros. Okay, so we still have to add a 0. 8 times 5 is 40. 8 times 50 is 400. So that's when your pattern can get a little bit tricky for you, okay? So when your basic fact has a 0 in it, that 0 from the basic fact doesn't count, okay, for the next number sentence, which is going to be that one that has just the 1 0. You're going to end up with 2 zeros in this case. Okay, 8 times 5 is 40. How many zeros are we going to add? 2. 8 times 5 is 40. How many zeros are we going to add? 3. Okay. All right, now remember that one because number 10 is going to be very similar. Okay, go ahead and pause the tutorial and I want you to complete 8, 9, and 10 now. All right, so let's check our answers. And we have 9 times 1, that's 9. 9 times 1 is 9 plus a 0, 90. 9 times 1 is 9 plus 2 zeros is 900. 9 times 1,000, well, 9 times 1 is 9 plus 3 zeros, 9,000. 3 times 7, 21. We know that. It's a basic fact from last week. 3 times 7 is still 21, but we're going to add a 0. Oop. 3 times 7 is 21. Add 2 zeros. 3 times 7 is 21. It's 3 times 7,000. Add 3 zeros. Okay, so we have this pattern of increasing zeros, and these increasing zeros help us to find the multiples of 100 and 1,000 and 10. Okay, all right, 6 times 5. What is the basic fact? 6 times 5 times 5, come on down, 30. So there's a 0 in our basic fact. Okay, that 0 does not count for this 0. 6 times 5 is 30. How many zeros are we going to add? 1. 6 times 5 is 30. 6 times 500. Add the 2 zeros. 3,000. 6 times 5 is 30. 6 times 5,000. Let's add 3 zeros. Okay, alrighty. So that is the intro here for the pattern of multiplying numbers that have 1 0 in the ones place, a 0 in the ones and the tens place, a 0 in the ones, tens, and the hundreds place. Okay, these are all multiples or creating multiples of 10, 100, and 1,000. Okay, so multiples of 1,000, okay, have 3 zeros. Multiples of 100 have 2 zeros. All right, we're going to use mental math. So again, this is that same process, but we don't have the layout now. Okay, they took away our training wheels here where we get to see a long pattern, but let's see if we can't solve a few of these without having our training wheels here. Okay, so we have 4 times 30. Well, what do? We looked for the basic fact. The basic fact is 4 times 3, that's 12. 4 times 30, add 1 0, 120. 6 times 40, well, 6 times 4 is 24, plus 1 0. 6 times 40, 240. 7 times 200, well, 7 times 2 is 14. Add your 2 zeros. 4 times 500, well, 4 times 5 is 20. Add your 2 zeros. If you got a 0 in the basic fact, like 4 times 5 is 20, that 0 does not count. Okay, so you still have to add 2 zeros. 3 times 9,000, 3 times 9 is 27, and add 3 zeros. 9 times 6,000, well, 9 times 6, and this is me using mental math. I'm talking to myself, okay, while I'm talking to you at the same time, but 9 times 6,000, well, 9 times 6 is 54. 9 times 6,000, add 3 zeros to the end of that answer, okay? All right, now we're going to get into that algebra component, okay? Part wholes here. We've got a whole and we've got a part. We've got the whole, the answer, and we've got one of the parts, okay? 6 times 7, okay? Well, if 6 times 7 is 42, right, then 6 times what is going to be 4,200? Same thing, okay? Look for the pattern, right? Remember, as we were moving down the list here, say in number 8, okay, our factor was 9 and 1, right? But we continued adding zeros to the factor of 1, so we end up with the factor of 10 and the factor of 100. Well, let's take a look here. Because if 6 times 7 is 42, then 6 times 7, not 7, but how many zeros are in 4,200? 1, 2. 700 is 4,200. Okay? All right. Number 18. 5 times 7 is 35. What can we use from 5 times 7, that basic fact here, to help us to figure out what this missing factor is, or the missing part for 3,500? Well, it's still going to have a 7. Okay, but how many zeros do we need to add? The basic fact was 5 times 7 is 35. Cover up all the zeros. How many zeros are there? 2. 5 times 700. 8 times 3 is 24. How can we use this fact family here to help us understand the missing factor, the missing part here, to find the answer of 2,400? Well, 8 times 3 is 24. Come over here. Make 24. There's 24. And how many zeros are you going to have to add to your 3? 2 of them. Okay. Alrighty. And then let's take a look. If 2 times 9 is 18, then 2 times what is 1,800? 2 times 9 is 18, and how many zeros do I need to add? 2. 1, 2. How many times greater? How many times greater? Okay. Is the product of 4 times 300 than the product of 4 times 30? Well, if you have 4 times 3, okay, and then you have 4 times 30, this is 10 times greater. Okay, so if we go from 4 times 30 to 4 times 300, okay, if you notice here, 10 times greater means that you add 1 zero. So if we're at 30 and then we go to 300, how many zeros did we add? We added 1 more. Okay, we went from 30 to 300. We added 1 extra zero, meaning that is 10 times greater. Now, if you go from 4 times 300 to 4 times 3,000, okay, again, we just added 1 zero. Okay, we went from 300 to 3,000, 10 times greater. But what about from 4 times 30 to 4 times 3,000? How many times greater is that? 4 times 30 to 300 was 10. 300 to 3,000 was 10. 10 times 10. 4 times 30 and 4 times 3,000. 4 times 3,000 is 100 times greater than 4 times 30. But that's way too big. Let's get back on track. 4 times 30 and 4 times 300. Well, how many times greater is the product of 4 times 300 than 4 times 30? Okay, you only got one space here, one extra zero. 10 times greater. Okay. All right, boys and girls. I hope we were feeling comfortable there, locating the pattern as we began the process of locating multiples of 10, 100, and 1,000. Okay, looking for the basic fact. How many zeros are you going to add to the answer?